Greetings viewers, and today's project is going to be about modifying a 10-circuit transfer switch from Reliance controls in order to handle an electric hot water heater. As you can see, I've already taken this apart. You could probably recognize what this is. Now, the main issue that you see with these transfer switches is that each of the branch circuits are either 15 amps or the two red ones here, which are 20 amps. The problem is that a lot of times an electric hot water heater, in my case anyway, maxes around 4,500 watts with both heating elements on. That puts you at about 18, close to 19 amps at 240 volts. Now, inside this transfer switch, it comes with standard 12 gauge wire. 12 gauge wire is right at the limit of, you could do up to 20 amps, but the problem is that since the electric hot water heater, they consider that by NEC code here in the United States to be a constant load. So you have to size the branch circuit for 125% of its rated load. That's why you normally see a double pole 30 amp or a double pole 25 amp and 10 gauge wire. Unfortunately, this transfer switch does not have that capability because it comes with 12 gauge wire, and it would not be up to code if you were to use it for backing up a hot water heater. Thankfully, it's an easy enough swap to make that compatible, and that involves changing out the 20 amp circuit breakers, push to reset circuit breakers in this case I'm doing a 25 amp, and changing out the 12 gauge wire for the two branch circuits here. There's 1, 2, 3, and 4 right here with some 10 gauge wire that can handle the amps. And what I have here is, this is the part number that you're going to need. This is again 25 amps, but you could go 30 amps depending on what your application is. This particular line of circuit breakers does go up to 30 amps. You're going to need a 3/16 thread with a D flat here. And what I mean by that is, if you could see it, one side is flat there. Now this is on the back panel, and one thing to keep in mind, this is the Pro-Tran series of transfer switches. At the time of recording this video, this transfer switch is now discontinued. They no longer make it. I'm told because that they weren't able to, at the time, find the circuit breakers beyond 20 amps. Now they do, and they are UL listed. 1077 is the code. The other thing too is that this modification I'm going to show you can only be done on the Pro-Tran series transfer switches. The previous generation Gen-Tran switches, you cannot make this modification, not without changing the single pole double throw switches here that has, line, off, and then generator. And the reason why, and I don't know if I'm going to be able to show you, but the Pro-Tran series are rated at 30 amps. The Gen-Tran series is rated at 20 amps, so you would have to replace these. Thankfully, it only cost me a couple dollars to replace the actual circuit breaker, and the wire was pretty cheap over at Home Depot. Now what you're going to notice immediately is that and this is why I tried my best to find it, see how those spade connectors are this way. I was only able to find the circuit breakers with the flat going this way. Unfortunately, I can't find them, not without buying them in bulk, and I only needed 2, so I'm going to have to make a little adapter piece here out of some jumper wire in order to make it fit. Not going to really show a lot of the work on camera here. This is pretty straightforward if you're familiar with electricity and dealing with wiring and crimping the wires, then this should be a piece of cake for you. I'm estimating you probably only take about half an hour to 40 minutes to do. And once you get it all put back together, then you can use you could set up the hot water heater on the whatever branch circuit that you want, and put the unitizing bar on the two switches so that you can use that for your hot water heater. And it would be code compliant, to my understanding, and you're also giving yourself the extra breathing room with the thicker wire and the proper size circuit breaker. And the last note that I'll mention here is that I could probably leave this configuration stock and still run the hot water heater. The problem that I would likely run into is that the 12 gauge wire would likely get pretty warm because it's considered a constant load, but I don't think it would cause any major issues. And I know a lot of people that just leave this transfer switch stock configuration and run their hot water heater. Some hot water heaters come in a variety of either 45, 4800 watts continuous, all the way up to 5500 watts continuous, and that really does put strain on 12 gauge wire. So 10 gauge wire is your best bet to prevent any potential issues. You don't want a fire or anything like that. As always, thank you for watching. Please note that this is a modification that will likely void your warranty on the switch if it still has it. Mine just happens to be out of it, so I don't really care. Be safe, and any questions, please feel free to leave a comment in the description down below. Cheers! So here's the final product here. I used these 10 gauge quick spade connectors, and then I had to loop it around so I can, and bend this lead so I can fit them. But it looks like it's going to work out just fine. And then changed out all the red and black wires and the jumpers here as well to be 10 gauge. So now this will handle easily 30 amps, but I have it fused, or I'm sorry, circuit breaker at 25.